Good morning, class. Here's Statistics, Module 1, Chapters 1, 2, 3. This is practice test number 1, everyone. So here's Chapter 3, Describing, Exploring, and Comparing Data. Chapter 3, Describing, Exploring, and Comparing Data. Number 1. The following data gives the number of hours that a few employees at the GM factory worked last week, 17, 28, 27, so on and so forth. Find the mean. There are other things that we want to find. So we're going to rank the data. N equals 18. There are 18 pieces, and we rank them from smallest to largest. Now, I want to make a note of something. We don't need to rank data for some calculations, such as finding the mean. However, it is a good practice to do so for those calculations that need ranked data. So what happens is that in other cases, such as finding the mode, median, mid-range, range, and so on, we will need to rank. So why don't we rank them in the first place so we don't make that mistake? Now, how do you find the mean? It has a simple formula. X bar is summation of X over N. So 14 plus 16 plus 17 all the way to 42, and then divide by N. That's why I put N is 18. There are 18 pieces. You do the math. As far as the number of decimals, if they don't tell you, you have to carry as many as possible. If they do, you do the rounding accordingly. Now find the mode. So you look at the numbers and there is no mode. Why not? Nothing repeats. Look at the numbers. No number repeats. So there is no mode. Find the median. Well, the median by definition is the middle term. So there are 18 pieces and there is no middle. The middle is between the 9th and the 10th one. 25 and 27 divided by 2. So when you rank the data, the median is the middle term. In the middle is right here. We don't have any. So when we end up with n being an even number, you have to add the two numbers in the middle. Divided by 2 becomes 26. Mid-range. Mid-range by definition is max plus mean divided by 2. Mid-range is the value midway between the max and mean. So the max, see, that's why when you rank them, it makes life easy. 42, and the smallest one is 14. So 42 plus 14 divided by 2, which is 28. Find the range. By definition, range is max minus mean. Okay, 42 minus 14 or 28. By the way, they just happen. Okay, so note R and MR. MR stands for mid-range, R stands for the range, are not equal in general. In this case, it happened by chance. It just happened that they are equal, and I wanted to mention it because I don't want any mistakes. They are normally different. All right, so we are continuing with this question, and we want to find more things. We want to find the variance. We want to find the standard deviation. So what is the definition? What is the formula? Sample variance, S squared is summation of X minus X bar quantity squared over N minus 1. Or N summation of X squared minus summation of X quantity squared over N times N minus 1. And I'm going to quickly show you how to calculate it by hand. Ultimately, things like that is done by technology like a calculator. But you need to understand the process in case, especially if you have a small size, data. So if we want to go with this one, n is 18, summation of x squared means 14 squared plus 16 squared plus 17 squared all the way to 42 squared minus summation of x, that means add them up to the second power. And by the way, we should have this value from the previous page when we did summation of x over n. This one is already there. And the denominator is n times n minus 1, 18 times 18 minus 1. You put it into a calculator, and this is almost 75, 74.9966673. I wanted to carry out many decimals so you can see that. If we want to go with this method, and again, I want you to see how it's calculated. When we say x minus x bar, okay, the very first number we have is 14. So 14 minus x bar, remember x bar is this number. So 14 minus this number squared plus 16 minus this number, 26.94444, quantity squared. And plus the last one, 42 minus this number, quantity squared. Add them all up and divide by n minus 1. And they both result in the same thing as far as the variance is concerned. This one. So whether you go this way or this way, you will get to the same answer. Which one is easier, you decide. And what is standard deviation is the square root of that. So remember, we really and normally we don't need the variance. We use variance to get to the standard deviation. So what is the standard deviation? Take a root of this number. So after you go through the process of finding the variance, then it's an easy part, just take a square root. Find IQR, inner quartile range. So first and foremost, what is that? IQR describes the middle 50% of values when ordered from lowest to highest. And by definition, is Q sub 3 minus Q sub 1. And we need to find those. Obviously, if you recall, we had the median. Okay. So this is Q sub 2. And then one easy way to find Q sub 1, just look at the bottom half, find the median, and Q sub 3, the top half, find the median. So this we already know, and it's 26. We called it Q sub, called it median. Median is Q sub 2. In other words, this is the value that separates the bottom 50% from the top 50%. Now Q1 separates the bottom 25% from the top 75%. So look at this. Okay, this is the bottom half. The median of the first half, or the bottom half, is the fifth one, and I meant here. So this is right in the middle. Why is this right in the middle? Because there are 9 numbers, an odd number. So fifth one is the middle one. And if you look at the top half, this is the middle. Okay. And that's number 34. So median of the second half of the data is 34. So this is done. I wanted to do this by hand, so you see how it's done. I want to show you with technology as well, but you need to understand the concept. Now, inner quartile range, therefore, let me erase my work, is Q sub 3 minus Q sub 1, 34 minus 26. Minus 20, my apologies, which is 40. the difference between these two. Now let's do TI. So we have the same question, the formulas. We know X bar, we know S, we know Q1, Q2, Q3. These are the stuff we found already by hand. But what about technology? And this is the rank data. So TI calculator, how to enter data to find descriptive statistics. You go to stat, clear list, and you go with one of them, for example, L1, and you plug in and so on. So stat, clear list, L1, okay, you're gonna edit, and you're gonna put the numbers. The numbers are 17, 38, 27. So you put it in L1, list number 1. So stat, clear list, or highlight and clear, edit, type in your data in L1. So that's what we have done here. Now we want the mean, standard deviation, 5-number summary. We go to stat, so we're still there. And now we click on calculation or calculate, and select 1. So calc, number 1 says 1 variable, stats, and we're going to type in L1. So 1 variable stat, L1, and enter. So this is what it gives us. And the arrow indicates there is more. So you go down and you get the second page. Now notice what you have here. So the calculator has done the work for you. You inputted the data. You did the calculation of 1 variable stats. So take a look. X bar, which we did already, is here. So X bar. X bar is the mean. S is the standard deviation. It's important to understand this one. We have S sub X and sigma X. This one is standard deviation for a sample. I hope you realize this was a sample, not a population. If it was a population, this would be the answer, sigma. So look at this number. What else do we have here? Okay, Q sub 1 is 20. Median or Q sub 2 is 26. Q sub 3 is 34. So everything that you want has been calculated for you. But again, you need to understand the process. Now, the calculation that you do and TI and other technologies may vary slightly. That's why you want to show work. And if something happens with the exam, I can look at it and give you partial credit. For example, using Excel. So Excel command, sort, input and select the data range, click the sort and sort A to Z or Z to A. So you put the numbers. Originally was 17, 38, 27. It wasn't sorted. Then you sort it, becomes the numbers that you see here. Now Excel command, descriptive stats, mean, standard of standard error, median, mode, so on and so forth. Make sure data analysis pack is added, data analysis, descriptive statistics, input range, so on and so forth. So I'm giving you the instruction as to how to do that. Okay. You can try this with Excel. If you have an Excel program, you can try this. And so it produces this one. So take a look. And this is for descriptive. By the way, you see the mean. You see the standard deviation, of course, with a lot more decimals. You see the range. And of course, minimum is number 14. Maximum is 42. and their differences, of course, is the range. Now, what about a Q1, Q2, Q3? You have to go with this one. To find Q1 quartile, the first quartile, you put the cell from cell and you put 1. If you put 2, gives you Q2. If you put 3, it gives you Q3. If you put 0, it gives you minimum. If you put 4, it gives you the maximum. So take a look. Example, quartile, D65 to D82. That's what I did. And then I put 1. And it gives me the numbers. Now, what I want you to see is this. Q sub 1 is 20.25, but we had 20. Q sub 2 has to be the same, and it is. And Q sub 3 is 33.25 instead of 34. Now, when n is huge, when n is very large, almost every technology gives you the same answer. But when n is not that large, they may vary slightly because there's a slight variation in calculation. That's why you want to show your work, and we want to look at it after you take the exam in case you didn't get a full credit, and we can give you full credit. IQ scores have a mean of 100 and a standard deviation of 15. Find the coefficient of variance. So let's see what we have. First and foremost, mu is 100, sigma is 15. Remember, mu versus x bar. Both of them are the mean. X bar is the mean for a sample. Mu represents the mean for the population. So we use Greek letters for the population. And for the standard deviation, S for the sample, sigma for the population. How do we know this is the population? It's referring to IQ scores, and it's not referring to a specific size of a sample. So what is the coefficient of variance? First, we have to write the given as we read. Then coefficient of variance, or CV for short, has the following definition. The coefficient of variance, or CV, describes the standard deviation relative to the mean and is used to compare standard deviation when the units are different. So in short, the ratio of these two, and of course, you change it to a percentage. So 15 over 100, and percentage means 15%. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. Well, according to the range rule of thumb, you start from the mean mu and you add and subtract 2 times the standard deviation. So mu plus minus 2 sigma. If you happen to have a sample, you would go with x bar plus minus 2s. So mu plus minus 2 sigma means 100 plus minus 2 times 50. And that gives you 70 to 130. That is known as the range rule of thumb. What it really means is that if you start from the mean and you go 2 standard deviation to the right, 2 standard deviation to the left, that's the range rule of thumb because it covers most everything, about 95% of the data. Using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130, and then the empirical rule. Same question. Using empirical rule, find that percentage. Now, we already have known from here that it's 2 standard deviations. So that means from the mean, you go 2 standard deviations away. So according to Chebyshev's theorem, the proportion of value from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is the number greater than 1. K is not necessarily an integer. So 1 minus 1 over 2 squared in this case. Remember, k is equal to 2. Okay, so 130 to 70. Okay, their difference is 60, which is 4 times sigma, by the way. That's one way to look at the concept as far as understanding the k. Okay, so k is the number of standard deviations. Their distance is 4 standard deviation divided by 2. Or think about this in the following manner. So let me just write it here. Here's mu, which is 100. To the left is 70. to the right is 130. What is this distance? 30. Now 30 is meaningless by itself. 30 means what? How many standard deviations? 2 of it. That's K. So 1 minus 1 over 2 squared, this is 1 over 4. 1 minus 1, 4, this is 3/4. 3/4 means 75%. So at least 75% have an IQ score of 70 to 130 according to Chebyshev's theory. When do we use that? When we don't know anything about the shape of the data. If we know it's symmetric with respect to the mean and it's bell-shaped, if it's bell-shaped, also known as normal distribution. Starting from the mean, go 1 standard deviation pluses and minuses. On each side, you get roughly about 6 to 8%. If you start from the mean and you go 2 standard deviations on each side, you get about 95%. And if you start from the mean and you go 3 standard deviations on each side, you get almost 100%. It's 99.7%. Now this one, we already decided that is 2 standard deviations. Therefore, the answer is 95%. So 95% will have an IQ score of 70 to 130. 70 to 130 are 2 standard deviations away from the mean. Given the data, 32, 19, 14, so on and so forth, rank it from the smallest to largest. Now, I want to explain something about this part. When you look at part B, prepare a box and whisker plot, you have to do this anyways, okay? So the smallest one is 3, the largest one is 50, so you put them in order. We have 3, 4, 5, and so on. So we put them in order, and that's what we get. So to prepare for box and whisker plot, we need 5 numbers. Okay. We need the mean, the max, Q1, Q2, Q3, and obviously we cut this into 2 pieces. You clearly see that right in between is Q sub 2. That means add this 2 divided by 2. So Q sub 2 is 50. There are different ways of finding Q sub 1 and Q sub 3. I showed you previously. You look at the bottom, half and the middle term. You look at the top half and the middle term. Those are Q1 and Q3. You can go that route. Again, that's one of the reasons that the numbers you come up with may be slightly different with the technology. So I'm going to go over that methodology also. And ultimately, if there is a discrepancy, you need to let me know. So n equals 14. We have 1, 2, 3, 4, 14 pieces of data. L is the locator, which want to say k over 100 times n. In other words, a specific location. And this is a percentage. Remember, Q sub 1 is 25%. So replace the k with 25, or just replace this one with 25%. Or just replace the k with 25. That is the same thing, everybody. And when you work it out, it gives you 3.5. Round up, you get 4. So it's the 4th piece of data. One, two, three, 4. Q1 becomes 7. We do exactly the same thing for Q sub 3, which is 75. So again, either put 75% or 75 over 100. It makes no difference. It means the same thing. And it gives you 10.5 rounded up 11. So that means number 11. So 11 piece of data. So this was 7, 8, 9, 10, 11. So Q sub 3 is 19. Now you go with the number line and you put those numbers. The minimum is number 3, the maximum is 50, so on and so forth. And here's what happens. The minimum, the maximum, and then Q1, Q2, and Q3, you make up a box like that. Okay, everybody? 3, 7, 15, 19, 50. This is called a box and V-skip plot. So we're going to continue with the same question where we have everything from the previous page. And now the question is, does this data set contain any outliers? Well, remember, a basic definition outlier is a number that is way out, but how do you find it mathematically? That's what we want to discuss. The values for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 times IQR are the fences that mark off the reasonable values from the outlier values. Outliers lie outside the fences. So let's go and find these values. Q sub 1 minus 1.5 IQR. So what is IQR? Q sub 3 minus Q sub 1. So Q sub 3 minus Q sub 1. 19 minus 7 is 12. We're going to multiply this by 1.5 and we get 18. So the idea is that if you subtract it from the Q1 and if you add it to Q3, those are the numbers that are the border lines. So Q sub 1 minus 1.5 IQR means 7 minus 18, which is minus 11. So that means minus 11 is the end. Anything smaller than that is an outlier, which obviously we don't have any. Now, for the larger side, Q sub 3, which is 19 plus 1.5, IQR plus 18, and they add up to 37. That means any number larger than 37 must be an outlier. So when you look at these numbers, on the left side, we don't have any. On the right side, 37. Okay, this is fine. Therefore, yes, we have an outlier, and that's number 50. So again, a basic definition, an outlier is that, it's something that it's out there. But how do you find that? You have to do it mathematically. And mathematically, just Q sub 1 minus 1.5 IQR and Q sub 3 plus 1.5 IQR. And we're done. However, I want to also add a data is considered an extreme outlier if its value is less than Q sub 1 minus 3 times IQR and plus that. So instead of 1.5, if we use 3, it becomes an extreme outlier. So IQR was 12. 3 times that is 36. So that means 7 minus 36, and that means 19 plus 36. So 7 minus 36, anything less than negative 29. And then Q sub 3 plus 3 IQR, 19 and 36, anything larger than 55 would be an extreme outlier. We're going to continue with the question, are the data symmetric or skewed? If skewed, are they skewed left or right, and so on? So I'm giving you the box and whisker plot we had come up with. Now there are a few notes I want you to pay attention to. Number one, note one, make sure the drawing is to scale. If this is not to scale, we may not recognize that. Number two, note two. Skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right or positive skew. The mean is larger than the median. Longer part on the left or below the median indicates data is skewed to the left or negative skew, in which case the mean is less than the median. Note number three, sometimes the box may look even or uneven and even skewed to the one side. However, the whiskers, that means those lines from Q sub 3 to the maximum, from Q sub 1 to the minimum, those are the whiskers, and this is the box. Tails on each side of the box may indicate otherwise. Therefore, pay attention to both. So how do we know this is skewed? It's very simple. You draw a line and you look at Q sub 2, which one is longer, to the left or to the right? If they are the same, okay, they are not skewed. They are symmetric. If they're not, then they are skewed. So as you can see, it's longer on the right side. It is skewed to the right. The mean is larger than the median. So it's very simple to figure it out. All right. Draw the box and whisker plot for the following data set. First, you have to rank it. It is already ranked. Cut them into two pieces. Again, you're dealing with an even number. In the middle, there is nothing. So you add these two divided by 2. That becomes the median or Q sub 2. So 86 and 87 divided by 2 or 86.5 is the median. Again, there are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way. This splits the list into two halves, the bottom half and the top half. If you look at the bottom half, 77, 79, 80, 86, and the top is 87 all the way to 99. Since the halves of the data set each contain an even number of value, the submedian will be the average of the middle two. Okay, so for example, for this one, just right here, might be easier to look at 79 plus 80 divided by 2. And this one, 87 plus 94 divided by 2. So the first one becomes 79.5. 87 plus 94 divided by 2, 90.5. So those are Q sub 1 and Q sub 3. As you recall, we looked at a different methodology, right? The locator, if you go back to those. So I want you to be exposed to both of them. Therefore, the 5 number summaries are as follows. Here's the minimum, here's the maximum, 77 and 99, and here's in between. And if you carefully do the drawing, it looks like this. That's the whisker and box plot. So what about the skewness and symmetry? Well, take a look at the location of Q sub 2. It appears that the left side and the right side are almost the same side. They may not be identical. Almost the same. Data is almost symmetric. It's called normal or bell-shaped. We are done with this, but I'd like to add a couple of things quickly. First of all, IQR was Q sub 3 minus Q sub 1. So 90.5 minus 79.5 is 11. So Q sub 1 minus 1.5 times IQR. So multiply this one by 1.5 and subtract it from Q1. You get 63. And do the same thing and add it to Q sub 3, you get 107. So any number smaller than 63 is considered an outlier. Any number larger than 107 is an outlier. We don't have any. And the extreme outliers, remember, we do 3 of them. So we get Q sub 1 minus 3IQR, 46.5, and Q sub 3 plus 3IQR, 121.5. There is a specific methodology of finding it. I just wanted to remind you. Also, I want to add something else. If n, so n is what? Even here, right? What happens if n is odd? So let's add some number. I'm going to write the same thing, and I've added 103 on purpose because I want to show you the difference, class. So if it's odd, in this case, 1, 2, 3, 4 on the left, 1, 2, 3, 4 on the right, this one in the middle. There are a total of 9. So the one right in the middle is Q sub 2, 87. Now, what about Q sub 1 and Q sub 3? You look at the bottom half and you include the median. Okay, so 77, 79, 80, 86, 87. So the answer is 80. And you look at top half and you include the median and it becomes 94. Now, this is what I mean by different methods. We've already discussed other methods. The third method is that they don't include Q sub 2. Mostly they do. In some cases, they don't, and they find Q1 and Q3 that way. I wanted you to be aware of that. Okay? So there are different ways of calculating it. And that's why you want to show work. All right, answer the following. If the mean of a set of data is 23, and 12.6 has a z-score of negative 1.3, then the standard deviation must be. Well, let's write the given. Mu is 23, z is negative 1.3, and this is called x, and the formula is z equals x minus mu over sigma. And everything is given. Sigma is missing, and I hope you realize if you do the cross product, you can put the sigma here and z here. This is elementary algebra. Or just plug in everything you have, find the missing one. So sigma is x, 12.6 minus mu, 23 over z, negative 1.3. You do the math, you get 8, and the answer becomes D. Z-score. And what is the advantage of the Z-score? So that's the answer. What is the advantage of the Z-score? This question tells us. Find the Z-score for each student and indicate which one is higher. When you are looking at different, method of, for example, grading, the Z-score, by the way, the Z-score of 0 corresponds to the average. Anything above is larger than 0 is above average. Anything below that is less than average. So Z is, for example, -1 doesn't mean the student received a negative value. So for the art measure, AM for short, and theater measure, TM for short, the numbers are 46 and 70, X bar is 50, S is 5 for the art measure. Okay, so let's calculate Z equals X minus X bar over S. It could be whether you're dealing with a sample. Sample uses this, and population uses that. So 46 is X minus 50 over 5, and we get -4 over 5 or -0.8. So what does this mean? Because it's in Z-score is negative, that means the student has received a grade which is less than the average. 0 means is equal to the average of the class. And above, if it's positive, it's larger than the average. We do the same thing for the theater measure. X minus X bar over S, and that means 70 minus 75 over 7. We get negative 0.7143. Now, both of them are negative, both of them are below average. Okay. But which one is higher? Well, this one, although both are negative, this one is less negative, so this is higher. Okay. So the theater measure has a higher score than the art major. And that's the idea to understand. If the five-number summary for a set of data is 0, 3, 6, 7, and 16, then the mean of this set of data is one of the following. Obviously, the answer is B. There is insufficient information to calculate the mean. You have only a few pieces, doesn't matter five or how many. You need every piece according to the formula. X bar is summation of x over n for a sample, or mu equals summation of x over n. This is the formula. These are in essence are the same, but this is representing a population. Add up all values in the data set and divide by the number of values. We need all data to do so. Anything missing, we can't do that. Which of the following is true? We need to understand the meaning of each one. First of all, the answer is part B, but why is that? D stands for deciles, measures of location that divide the data into 10 equal parts. 10 equal parts. That is decile. Percentiles, measure of location that divide the data into how many? 100 equal parts. 100 equal parts, and that's the key. So P. What about Q or quartile? Measures of location that divide the data into 4 equal parts. So D5, P50, or Q2, they mean the same thing according to the definition that was just mentioned. A student received the following grades: an A in statistics, which is 4 units or 4 credits, F in physics, which is 5 credits, B in sociology 3, B in literature 2, and D in tennis 1 unit. A is worth 4 points, B is worth 3 points, C is worth 2, D is worth 1, and F is worth 0 points. The student's grade point average is, we are going to calculate the GPA using the weighted average or weighted mean. When different X data values are assigned different weights W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products of by the sum of the weights. In other words, this is the formula. The reason is very simple. Just imagine you have only 2 courses. One of them is A, one of them is B. That's all. So A is 4, B is 3. So the average is 3.5. Well, it depends. For example, if the A course is worth 5 units, but the B course is worth only 2 units, it's not fair, right? It should be more than 3.5, or vice versa, should be less. So that's why we use the weighted average. So let's write down. So we have A, F, B, B, D. Those are the grades that we received. Okay. In statistics, that is 4, physics, that is 5, and so forth. So the weights are statistics 4, physics 5, sociology 3, literature 2, tennis 1. So, and how many points are they worth? Okay. Well, A is worth 4 points, F is worth 0, B and B, both of them, each one is 3, and D is 1. So according to this, you multiply this column by this column, and you divide by the total number of units. So 4 times 4, plus 5 times 0, plus 3 times 3, plus 2 times 3, plus 1 times 1, divided by 4, plus 5, plus 3, plus 2, plus 1. That is the weighted average. Of course, 16, this is 0, this is 9, 6 and 1, we get 32 divided by 15, about 2.133. Normally we report with 2 decimals. So probably this would be the answer, but just follow the instruction. Okay. But never less than 2, okay? You go with at least 2 decimals. That's how GPA is calculated. Given the data, 10, 44, and so on, find the value of the corresponding to the 75th percentile and so on. Let's rank the data immediately. The smallest one is 10, and 14, 15, and the last one is 72. So we're going to rank the data. And then we go with this locator thing. N is 8. We have 8 pieces of data, 1, 2, 3, 4, 5, 6, 7, 8. And location L is K over 100 times N. We want 75th percentile. So either replace this entire thing with 0.75 or 75%, or replace the K with 75 in the first case. And remember, N is 8, so 6. It so happened the methodology class, whenever you get to a whole number, you have to go in between that one and the next one. Since 6 is a whole number, 6 plus 7 divided by 2. Okay. So 1, 2, 3, 4, 5, 6. This is the one. So right in between these two. That's the methodology. And we get number 50. 30th percentile, we do the same thing. Same thing as here. Replace the 75 with 30, do the math. You get 2.4. Now, when you get a decimal methodology, always round up and it becomes the third value. 1, 2, 3, the third value is 15. Find the percentile corresponding to number 44. The methodology is to look at the number of values less than 44 divided by n. So anything less than 44 divided by n. 1, 2, 3, 4, 5. These 5 numbers are less than 44. This is the formula. Number of values less than 44. 1, 2, 3, 4, 5 divided by n, which is 8. 5 over 8. And you round it accordingly. 0.625. That means P63. This means 62.5% exactly, so roughly 63%, okay? You have to round it accordingly. Using range rule of thumb, estimate the standard deviation. So reminding everyone, according to the range rule of thumb, mu plus minus 2 sigma or x bar plus minus 2s, that is the range rule of thumb. So estimating value of the standard deviation happens to be to roughly estimate the standard deviation from a collection of known sample, S is range divided by 4. So range divided by 4, max minus mean. So rank data 72 minus 10 divided by 4, which is 15.5. So that's how you use the range rule of thumb. Otherwise, you have to go to the formula, the summation of x minus x bar, 180 squared over n minus 1, and you take a root. Okay, that's the exact answer. This is a rough estimate, and they're pretty close. The following data represents number of keyboards assembled for a sample of 25 days in a company. That's a sample. Construct a frequency distribution table with 4 classes. Well, what is the process of finding that? First of all, let's rank the data. It makes life easier. Then if you are going to set up so many, they tell you how many classes. If you're on your own, you make a decision. You don't want to go with too many. So what you need to calculate is the width. The width is the range divided by the number of classes. So 56 minus 41 divided by 4 is 3.75. So this would be the number that you need. You always round up to make it easier. You don't want to put 3.75 as a width. And so when you round up, then it becomes 4. Please understand, don't mix them up. This has got nothing to do with it. Now, if you round down, trust me, you won't get to all of those numbers. So we have the number of classes, we have the width. Where do we begin? What is the lower limit of the first class? Lower limit of the first class or starting point is a convenient number less than or equal to the smallest value such as 41. So if you look at this one, okay, you can get 41 or any number less than that, but you have to be logical in the following manner. If you start, let's say, with 30, that's way too small. You will not get to the last number when you work it out. Even if you work out, if you start with 40, you may or may not get to that. That's why you want to be careful. So I'm going to start with 41, but probably 40 works, and I highly recommend for everybody to try it. So it's not unique, because what happens as far as the exam, you will be given the lower limit. If you are on your own, then the classes may be slightly different. So if the width is 4, remember, if you go with the column, we can find the lower limits for each one. So 41, the width is 4, becomes 45, 49, 53. So that we know. Okay. And then over here, I hope you remember that if you go with the same row, upper limit minus lower limit plus 1 unit. Okay, so if I put that, let me just, so upper limit minus lower limit plus 1 is the width. So upper limit, I'm looking at this one, for example, minus lower limit, which is 41, plus 1, 41, equals 4. And then you can find the upper limit. I'm assuming everybody can calculate this to be 44. So if this is 44, then you add the width 4 here and here and here. Let me erase my board. So as long as you get one of them, then you can add the width to find the rest of it. So 41 to 44. So 41 to 44, you write them. Let me just write it in this fashion. 41 to 44, I have 1, 2, 3, 4, 5 here. 45 to 48. When you go with the limits, the end limits are included, the lower and the upper. So from 45 to 48, you have those 1, 2, 3, 4, 5, 6, 7, 8. So the next one is 8. The next one is also 8. And the last one, 1, 2, 3, 4. So you put 5, 8, 8, 4. That is, this entire thing is FDT, frequency distribution table, which means you have the classes, you have the frequencies. Now I'm going to continue with the question and says, use the data to find the median. The data was 45, 52, and so forth. Add them up, divide by size. So 45, 52, and the rest of them divide by 25. And that's easy to find X bar 48.48, and you're done. Now, this is the exact value. Use the frequency distribution table to find the mean. Now we can approximate it. If we didn't have the data, original data. In some cases, we don't. Then how do we do that? And that's the key. In that case, we use the formula x bar is summation of fx sub m times n. So what is that? The frequency. The thing is, you don't know what you have here. You know that you have 5 of those. What are they each? You have no idea. So you do your best estimate. What would be the estimate? You assume each and every one is equal to the midpoint. So you find the midpoint here, 44 plus 41 divided by 2, which is 42.5. So FDT does not give us every piece of data. So we use X sub M, which is the midpoint of each class. So this one, 41 plus 44 divided by 2 or 42.5. And now, because we know the width is 4, just you don't have, you can calculate it or just add 4 here. 46.5, 50.5, 54 point. So you are assuming that instead of what we have in between, you have 5 of those, 8 of those, 8 of those, 4 of those, and you follow that. That's the idea behind this methodology. So 5 times this number plus 8 times this number, and so on, divided by n, which is 25. That 25 doesn't change. You do the math, you end up with 48.25. Are the two means reasonably close? Of course they are. Take a look. Here's the mean, precisely 48.48. And here's the mean that we calculated using the FDT, frequency distribution table. They are reasonably close.